Question 16. Where 3 marks, solve algebraically, n choose 2 equals 4n plus 5. So this is noticeably on the non-calculator part. And they want it, of course, solved algebraically. So trial and error, just putting in random values for n and seeing if it satisfies the equation will not work. So we have to use our formula as the first step. So the formula for n choose r, just to remind you, is n factorial all over n minus r factorial times r factorial. So that's our formula that we're going to use right away. The thing is we know 2. We know the value of 2, so I'm going to substitute that in. So this is equivalent to n factorial all over n minus 2 factorial times 2 factorial. And this is equivalent to 4 times n plus 5. So whenever you have factorial notation, we certainly know what it means. 10 factorial is 10 times 9 times 8 times 7 all the way down to times 2 times 1. So you always want to expand the largest part of your equation. So we're going to compare n factorial versus n minus 2. What's larger? Well, obviously, n minus 2 would be smaller because it's 2 less than n. So we're going to expand the top, and I'm going to go n. Now, what's before n? Before n is n minus 1. Now, what is, put brackets because it's a binomial. What is before n minus 1? Well, that would be n minus 2. And I could say, n minus 3, n minus 4, but I'm going to stop right there. Whenever you stop a factorial expansion, you have to end it with a factorial. And the reason I am ending that expansion is because I already have n minus 2 on the bottom, n minus 2 factorial. So the only time you can cancel is when you have multiplication and division, and this involves straight division, and it would leave me a 1. The right hand side is unaffected. It is still 4n plus 5. So if we continue to do this problem, I think we got a much better equation now to deal with. So we have n times n minus 1. 2 factorial is 2 times 1, so I'm just going to put down 2. And that's 4n plus 5. So it looks like we're going to get some type of quadratic. And I'm just going to multiply both sides of this equation by 2. So multiply that by 2. Multiply this by 2. So of course the 2's go away here. And I'm left with n outside of n minus 1 equal to, and I'll expand that to 8n plus 5. And I guess I could have expanded on the last step. This is a quadratic. So we have n squared minus n, and that equals 8n plus 5. And we know that when we're solving quadratics, quadratics should equal 0 in order for us to get the correct answer and, well, to factor it. Hopefully this will factor. It's on a non-calculator part, so it should. So what do we want to do here? Well, the first thing I'm going to do is subtract 8n. Subtract 8n. So what do I get? I'm n squared minus 9n. And then, of course, you can bring the 5 over, subtract 5 to both sides. And then we get that. Now, I made a big mistake. I'm thinking this thing doesn't factor. I got to backtrack a little bit. 5 times 2. So, a strategy here is when something doesn't factor, you probably are okay. You just made a mistake earlier. 5 times 2, right here, right, is 10. I don't know why I didn't write in my distribute arrows. There we go. So 5 times 2 is 10. So that's a 10. That's a 10. So this is a minus 10. Aha, now it factors. So of course I want to multiply to get negative 10, add to get negative 9, some combination of 10 and 1. because I want to get a negative 9, my 10 should be negative. So my factors are n minus 10 and n plus 1. So my solutions are going to be n equals 10 and n equals negative 1. You should always check your solutions and verify, see if they are right. So I'm going to go up top. I'm just going to do a quick check. All right, so 10 is certainly possible to be substituted in for n. You got 10 objects and you're choosing 2, and you're going to end up with 45. So let's just see if that's the case. 10 choose 2. Let's just test it out. 10 choose 2. 10 factorial n minus r. So that's 8 factorial, 2 factorial. So that's 10 times 9 times 8. Right? The 8's cancel. 2 is just 2 times 1. So that's 90 divided by 2, which is 45. And if we check the right-hand side, 4 times 10 is 40. 40 plus 5 is 45. So this is definitely good. Okay? This is great. We're just checking it, which is good. It equals the other side. The negative 1, however, doesn't make any sense in this context. You can't have negative 1 objects and choose 2 of them. Okay, so we want to just convince that we know what's going on. Lightly cross out this one and circle that one. All right, so that is it for question 16.